Hi Guy, I'm Larei from AI Elephant.
Hi guys, I'm Leo.
Welcome to the show. Leo, we talk about AI all the time, and there is always something new. But recently, one word keeps popping up, agent.
Agent? I feel like isn't that just a premium name for a chatbot? Just rebranding it to sound more impressive?
That is actually the biggest misconception. A chatbot waits for your questions and answers them. An agent can proactively do things for you. It is not just a brain, it has hands and feet.
Oh, proactively do things?
Exactly. Today, we're going to dive deep into how AI evolved from chatting to executing. Based on insights from Google, we'll explore the revolutionary changes agents bring and a much grander future, an agentic web driven by the collaboration of countless agents. To understand agents, we have to look at the evolutionary path of AI. It is very clear, and it basically happened in 4 steps.
4 steps? What are they?
Step 1 is the basic LLM large language model, like early Gemini. You give it a prompt, it gives you an answer. That is Q2A.
We're all familiar with that one.
Step 2. We weren't satisfied with it only using its known knowledge, so RAG Retrieval-Augmented Generation emerged. The model can retrieve external private data or knowledge bases before answering you. Its knowledge expanded.
Right, so it can cite its sources, so to speak.
Step 3. We wanted it to not just talk, but to do. This led to tools calling. For example, you ask for the weather, it doesn't just guess. It actually calls a weather API, gets the data, and then tells you.
So where does the agent fit in?
The agent is step 4. It is the fusion of all previous abilities, and it creates a fundamental change. It is no longer just calling one tool. It possesses a reasoning loop. It thinks for itself. To complete this complex task, I should first call tool A, get the result, analyze it, then call tool B and tool C.
I think I get it. A chatbot is, I'll do what you tell me to do. An agent is, you tell me the goal, and I'll figure out how to get it done.
Exactly right. This brings 4 revolutionary changes. First, autonomous action. It doesn't wait for instructions. It can proactively execute complex processes. Second, reasoning and planning. It thinks for itself and can even self-correct when it hits a problem. Third, continuous learning. It accumulates experience during execution, getting smarter and understanding you better over time.
And the 4th one.
The 4th, and most powerful, multi-agent collaboration. This multi-agent collaboration is key to the future of agents. Just like in human society, solving complex problems relies on a team of specialists, not one jack of all trades.
AI needs to team up. How do they even talk to each other?
This is the core problem Google is trying to solve. In a company, you might have an Expedia agent for booking tickets, and SAP agent for expenses, and a Slack agent for approvals.
Hold on, I think I see where you're going. If I need to go on a business trip, right now I have to go to Expedia, book the flight, screenshot it, then go to SAP to fill out the expense form, and finally paste a link to my boss for approval, right?
Exactly. The process is fragmented. But in the world of agents, you just tell your root agent, handle my business trip to Hangzhou next week. Budget is $500.
And
Then your root agent activates. It automatically discovers and delegates tasks. It first contacts the booking agent to secure the flight and hotel. Then, it sends the order info to the expense agent to automatically generate the expense report. Finally, it pushes the request to the approval agent to wait for your boss's click.
And I don't have to do anything. How is that possible? Are all their backends connected?
This is precisely the value of the AAA protocol, the agent to agent protocol that Google has proposed. The AI protocol is what you can think of as the diplomatic language or common standard for agents. The Expedia agent and the SAP agent have completely different internal systems. They are black boxes to each other, but they both agree to use the AI language for external communication.
So AI is like the lingua franca of the agent world.
A good analogy. When Agent A wants to ask Agent B for help, it first needs to discover. Agent B provides an agent card.
A business card! What is on it? I elite Agent B.
Chuckles close. It is a JSON file that standardly lists who I am, what skills I have, what input format I accept, and what my contact address is. Once A gets the card, it knows how to talk to B. It sends a standardized message via RPC remote procedure call. If the task is simple, B returns the result immediately.
But expense approval isn't simple. The boss might not see it for hours. Does it have to just wait online?
Great question. This is where the asynchronous priority design of the AI protocol comes in. For complex tasks, when B receives the request, it immediately replies to a task created. ID is Yawar Sen. I'm processing it.
So how does a know when B is finished?
A cool D used polling, asking B every few minutes, how is task 123 doing? But that is very inefficient. That is why AI recommends using SSE servers and side events. Agent Adjust keeps a connection open, and Agent B will proactively push status updates through this stream. Task E by Arshasen Mouse you emitted for approval. Task Yawar Sen approved by boss. Task Yawar Sen complete. It is much more efficient.
This all sounds great, but are these agents far off, or does Google have any practical examples?
They definitely do. The most famous vision prototype is Project Astra. It is an assistant that can hear, see, and understand your surroundings.
That one. The one where you can be interrupted mid-conversation, and it still remembers what you were talking about. It maintains in-session memory.
That is the one. It can also understand the parts on your desk, help you find a tutorial on YouTube, or even find the dimensions in your email. That is a classic multimodal, cross-application agent. There is another, more grounded prototype called Mariner. It is a Chrome browser plugin. Through it, the large model can understand the pixels, text, and forms on your screen.
Isn't that just browser automation?
Yes. For example, you can give it a Google Sheet with 100 companies. Mariner will automatically open new tabs, search for each company's website, find the Contact Us page, and copy the email address back into the sheet.
That is a huge time saver, and I heard that while it is working, you can pause it and actually see what it is thinking. It's reasoning.
Exactly. That kind of transparency is important. It proves agents aren't science fiction. They are entering our workflows right now. So we've talked about what agents can do AA collaboration and seen examples Mariner. How do developers actually build their own? For this, Google provides a complete agent stack.
The full stack again, laughs. What is included?
Laughs pretty much. First, at the bottom, is the brain, the Gemini family of models, providing reasoning. Second is the body and skeleton, the ADK Agent Development Kit.
ADK. Another SDK?
It is an open source client SDK, and it is critical. It saves developers from worrying about the low-level details of tool calling, workflow orchestration, and session management. ADK packages all that grunt work. For instance, in ADK, you can define an agent's persona instruction and its tools in just a few lines of code. You can even nest agents, having a root agent call a research agent as a subtask.
I get it. ADK is the agent construction kit, and an API is the communication protocol they use several after they're built.
Precisely. Finally, the agent you build needs a place to live. Host that is the Vertex AI Agent Engine. It is a fully managed cloud platform that handles scaling, security, and monitoring for you.
Larei, I have a question. Google provides the Gemini brain, the ATK body, and the agent engine habitat. Are they trying to create a monopoly? If I use ATK, am I forced to use Gemini?
This is actually the most interesting part of Google's agent strategy. The answer is no. The design philosophy of ADK is model agnostic.
Model agnostic!
Yes, ADK has an LM core inside. It defaults to Gemini, but it allows you to plug in any other model, whether it is closed source or open source.
Wow, that is a very open approach. It is like Google is providing the car blueprints ADK, but letting you choose your own engine, LLM.
And not just that, it is also deployment agnostic. The agent you build with ADTA, once packaged as a container image, can be deployed on Google Cloud, on-premises local, or on any other cloud platform.
So Google's strategy isn't to lock in developers. It is to attract everyone to co-build this agentic web ecosystem by providing the best tools, ADK, and the most open protocol, AA.
Exactly. It is betting on the openness of the ecosystem, not the exclusiveness of its platform. So, looking back, the agent is no longer a distant concept. It evolved from QTAA LLM to Retrieval-RAG to execution tools, and finally into a new species that can act, plan, and collaborate autonomously.
And the ADK and AA protocols from Google are designed to lower the barrier to building them and allow them to team up.
Finally, for all of this to happen at scale, the brain, the LLM, must be both powerful and cheap. This is why Google emphasizes the Pareto frontier for its Gemini family.
Pareto frontier?
To quote Jenny Shi, it is summarized as, "The strongest is the cheapest, and the cheapest is the strongest. Only when the operating cost of the agent's brain is low enough, and its performance high enough, can an agentic web and internet of billions of agents collaborating to complete complex tasks for us truly be realized."
An internet where we no longer have to operate things manually, but one that understands our intent and collaborates proactively. That certainly sounds like a future worth looking forward to. Thanks for the insights today, Larei.
Thanks for listening.